Welcome back to another lecture. So last lecture, we tried to go how to predict whether the reaction is going to move on forward or not. And term that we followed was this, RU. And A stand for atom, R for resonance, I in induction, and O for orbitals. And we said if you're dealing with two elements that they are in the same period, if you're dealing with two elements, the one that is bigger, it can easily handle the negative charge, and it will give you a more stable conjugate base. So that means the starting compound will be more acidic. And in this case, we have carbon versus oxygen. Carbon versus oxygen. Carbon and oxygen are in the same period. So if you're talking about their sizes are the same. If the size cannot help you, then you move with the electronegativity. The one that is more electronegative, it can easier handle the negative charge whenever you form a conjugate base. So that conjugated will be more stable. That means your starting compound will be stronger acid. And we said this, okay, this one, because it has carbon versus oxygen, and oxygen is more electronegative than carbon, so oxygen is more capable of handling the negative charge. That means the propanol is going to be stronger acid, okay, or stronger acid than butane. So this one, it will be more acidic than butane. Okay, now, and how about this? If we, for example, do this one with, say, I put here, let's say, oxygen versus here, oxygen attached to hydrogen. And next one, I go the same thing, but I go sulfur versus hydrogen. Okay. Now, size for sulfur is bigger than size of oxygen. So that means the one that has sulfur, it will be more acidic. Okay, more acidic than an OH. Okay, even the electronegativity of oxygen is higher than sulfur, but sulfur, because it's bigger, it can easier handle the negative charge. Okay, now the second term that we need to follow it is going to be resonance. So what will happen after forming the negative charge or the forming the conjugate base? Okay, what will happen with the negative charge after forming the conjugate base? Okay, is it localized or delocalized? Okay, so listen carefully. Is it localized or delocalized? If it's localized, less stable. If it's delocalized, that means it moved over 2 or 3 elements. That system is more stable. Okay, let's take these two. Okay, let's say we have a base reacting with ethanol or with acetic acid. Which one is a stronger acid? Okay, so the first one is going to give me this. It's going to give me HB plus, okay, and I get this. Oxygen with 3 lone pairs. Oxygen is -1. Okay, how about this? I get HB plus, then I get, again, oxygen with a 3 lone pair, and this one is -1. Okay, now the question, can we draw any resonance structure? For the first one, no. Okay, first one, no resonance structure at all. The second one, yes, you can do resonance structure. You have 2 oxygen, 1 and 2. Okay, the one that is yellow, it has 2 lone pairs, and the blue one, and it has 3 lone pairs. Can I share this? Forgive me. Can I share this lone pair, one of this lone pair, and put it here, and then move these 2 electrons? Move those 2 electrons and put them top of oxygen? Yes, that's possible. Okay, and if we draw the resonance structure for it, it will be like this. Oxygen with 3 lone pairs. And now we have 3 lone pairs, and this is the new lone pair on it. And next, you have this oxygen attached to carbon through a double bond. And oxygen is going to have only 2 lone pairs. Okay, so this is the oxygen that gave 1 lone pair, and that one, the one that accepted lone pair. Okay, so now what happened? Look to the double bond. Used to be, you know, with the yellow one, now with the blue one. Okay, so I managed to distribute technically the negative charge. Okay, negative charge over to oxygen. In reality, I got this. Okay, I got this. So if I want to draw a structure for both of them, this is going to be the structure. I have carbon attached to oxygen, another oxygen here, and we have a carbon. Okay. And what happened with the negative charge? Negative charge, it can be here or there, correct? And so I'm going to draw it as dot like that. And I say negative charge, it can be anywhere on those three atoms. So I have carbon. Okay, I'm going to highlight them. I have oxygen, carbon, oxygen. Negative charge is distributed over three atoms. Remember this that we said ratio of charge to volume. If this one goes down, the system will be more stable. Okay. Charge is not changing, it's -1, but the volume, instead of one atom, for the first example, we have only one atom. The negative charge was located at just one oxygen. Okay, -1 over one oxygen. Now -1 is distributed over three atoms, and because the volume gets bigger, system will be more stable. So now, question is the question or the points that I want to say it, or we need to know. We need to kind of like be careful about it. Okay, what will happen if we get resonance structure? Okay, if we get resonance structure, we can easily distribute the charge. Okay. And because we can easily distribute the charge, the conjugate base will be more stable. So I'm going to write here. I'm going to say the conjugate base got more stable. Through what? Through resonance structure, through the resonance structure. And this is going to move the chemical reaction to the right side. Okay, so if I compare these two, I'm going to say this one is more acidic. Okay, so call this one, for example, call this one 1 and call that one 2. 2 is more acidic. Why? Because it can generate two resonance structures for the conjugate base. So the first term was the size of the element or the electronegativity of the element. The second one is going to be the resonance structure. Can we get more than one resonance structure? If that's the answer, if the answer is yes, then that acid, it will be a stronger acid. Okay, and as you see, this one is not capable of forming any resonance structure. Okay, while acetic acid, it can generate two of them. We got two resonance structures, so our conjugate base, it will be more stable, and versus this one, which is localized, and here you should say delocalized. The delocalized is more stable than localized, and that means acetic acid is more acidic than ethanol. Okay, so acetic acid is more acidic than ethanol. Okay, next term, it will be the induction. Okay, the induction. And what's the induction? Okay, now, when you generate a negative charge, if you can distribute it over a couple of atoms, that's good news. If you cannot, is there any way, instead of resonance structures, is there any way to pull it far from one atom, and instead of leaving it sitting or localized in one atom, can we attach electronegative element, and that electronegative element is going to apply some like pulling effect to pull it to itself and kind of like move it away, for example, from oxygen? If the answer is yes, that system will be stable. Okay, it gets more stable. The more electronegative element you have, the higher stabilization you will see with the conjugate base. Listen careful again. The more electron withdrawing group you have, or what? Electronegative group you have, the higher stabilization you will see. Why do I keep saying higher stabilization you will see, or that conjugated will be more stable? Okay, how about this? Less reactive. Why? Because in order to react, you need to have electron. If somebody is stealing your electron, you don't have electron to get involved in any chemical reaction. Your electron is taken because you don't have any electron now, or your electrons are kind of like they are shifted to another side. You don't have much tendency to react. And if you don't have, we say you're stable, you're happy with the situation. Okay, so as you see in all of them, okay, we do have resonance structure. If I, for example, react with the base, that's going to give me HB plus, and what else? I get this. Okay. Or okay, I can say I get double bond here, and this oxygen will have 3 lone pairs. So any of this is possible, okay? And I'm going to say these two are resonance structure. One, okay. These two are technically identical. The only difference, the charge 0, -1. This one is -1, and that one is 0. Okay, how about this structure? This structure, if you reacted with B, you will get HB plus, and again, you get the same thing. And you have carbon that attached to 3 chlorines. Chlorine has really high electronegativity. So I'm going to say electronegativity of chlorine is higher than electronegativity of carbon. Why carbon? Because this element is carbon. That element is carbon. So now what will happen? Okay, again, you're going to get the same resonance structures. You're going to get another structure, and this structure, it will be like this. Double bond here. I get carbon attached to 3 chlorines. So I have 2 resonance structure. Okay, 2 resonance structure exactly similar to the previous one. Okay. I got the same thing here. The only difference between them, carbon. Carbon is less electronegative than, less electronegative than the central carbon. Why? Okay, let's zoom here. Okay, this carbon is sp3. Well, that carbon is sp2. So what will happen? Carbon will donate electron to the central atom. Okay, will donate electron to the central atom. How about there? How about here? Okay, in this case, I can say, yes, again, I have sp2 here, and this one is sp3. But look, instead of hydrogen, instead of carbon with 3 hydrogen atoms, we have chlorine, and the chlorine is more electronegative than hydrogen. So this is going to happen. Chlorine is going to pull, and it will create a positive charge on carbon. So now that carbon is missing plenty, technically negative charge. And maybe it's not going to donate much electron to the central one. If it's donating, it's not going to be a lot. But in fact, this is going to be pulling electron. Okay, it will pull some electron from the sp2 carbon. Why? Because we have 3 chlorine attached to it. The more chlorine you have, the higher attraction force. Okay, I should not say attraction, the higher pulling effect or induction effect. Technically, you're pulling more electrons from sp2 carbon. And the bottom line of it, this negative charge, instead of being between this only 2 oxygen and 1 carbon, very soon it will be pulled these directions. Okay, so it will be distributed over entire of the molecule, not just 3 atoms, entire of the molecule. Again, if you can distribute it over entire of the molecule, the system will be more happy, more stable. So if I compare them, which one is more stable? The one that has, which one is the strongest acid? The one that has more chlorine. Okay, and if I show the pKa for you, okay, look to the pKa. Okay, the one with the lowest pKa, it will be the strongest acid. So this one, it will be the strongest acid. Okay, I believe we have a question, and this is the question. Okay, so a question that you need to ask it: or these molecules based on their acidity. Which one of them has the highest acidity? Okay, which one of them has the highest acidity or the strongest acid? Okay, so this is going to be a question, and it will show up on you on the video, and you need to pause the video and answer it, and answer the question, and then submit it. Thank you very much.